Good morning. Thank you for joining us for the webinar on Paths to Insight. I can see we've got around about 50 participants at the moment, so we're very excited about this webinar. We found that it's generated a great deal of interest, so hopefully you can stay with us for the duration of the webinar. I will be co-hosting with two colleagues from our Canberra office, Abhishek and Matthew, who I'll be handing over to at points during the presentation. So without further ado, let's continue. So the webinar is really touching on one of my favorite questions I get asked by customers, which is, how do we actually get these insights that we hear about so often? I'll describe with the aid of my colleagues the four approaches that we have available, which typically we find. You'll probably find that there are a blend of experiences that you'll have in the real world, but very often the path to an insight is one of four. And then we'll draw some conclusions at the end of the webinar. As I mentioned before, we have a large number of participants from Australia and New Zealand at the moment. And for those of you who already know us, thank you for joining us. But interestingly, for those who are new to Altis Consulting, a little bit about us. So we are a vendor-independent organisation, and we've been in the data analytics space for 20 years. We've got offices in London, Brisbane, Sydney, Canberra, Victoria and Auckland. We pride ourselves obviously in our technical know-how, but what differentiates us from other consultancies in the same space is our passion to connect with our customers, the courage to have those difficult conversations, which are always important that we have to challenge preconceptions about issues or give guidance on direction. We are passionate about what we do, so we always have heart in what we pursue. And to coin a phrase relating to this presentation, we believe in delivering insights. To a little bit of housekeeping, during the webinar, please feel free to use the Q&A options available to ask questions. We will try and get to as many as we can at the end of the webinar. We'll also be communicating post the webinar via email, and we'll be sending out some supporting information and a link to this video, which will also be on YouTube. So the issue. So as an industry, we're very good at promoting the opportunities that data analytics provide. So we often discuss, we take this raw data that's available, and we model it and we transform it and we apply algorithms and we model it and we'll provide visualizations, all with that goal of delivering an actionable insight, which is obviously what the end game of any engagement really should be focused upon. But very often we don't tell a client, a customer, a user, how do you get to these actionable insights? We describe it as a potential, but how do we realize that potential? So in some ways, an actionable insight is really that needle in the haystack, that gotcha moment where we've set out to find something interesting. We may have a preconception of what it is that we're going to find, or we may just be doing some discovery. We may not know what we're going to find, but we need to keep an acute look on what we come across and see if there's anything unusual that is emerging from the data. So for me, an insight is where we gain a deeper understanding of an existing issue. And in order for it to be actionable, then it needs to have relevance. It can't just be a mild curiosity, because then where is the value in that? And what we want it to do is lead to a specific response. So we've understood something more completely. The understanding that we've gained has real relevance to the organization, and it elicits a specific response to that greater understanding. Some examples of insights that I've come across in my career, most of these are quite recent. An interesting one was predicting incidents in a construction company. So what we found was that projects that were under stress through schedule or budget had a greater incidence of safety incidents or potential safety incidents. And so what then was done as a response was additional safety training was provided to the employees and the contractors that were on the site in order to prevent those safety incidents. So it's not always about profit and efficiency and revenue. You know, insights can occur through a number of different channels, and I think safety, we all agree, would be one of the most important ones. Churning of customers or students, you know, whether it's a university or whether it's a long-held customer at a telco, you know, being able to predict that that they're no longer as engaged as they were in the past, and intervening to retain them and prevent that loss of revenue or the loss of the students as they pursue their academic career. Some other typical ones you'll find are equipment failures. How do we get an insight into a failure that may occur, and then making sure that we maintain that equipment prior to that failure. And that could be major infrastructure like power distribution, could be a locomotive moving goods around Australia. So there's a number of different situations there where a greater insight into a potential negative activity is really valuable to have. This slide is a continuation of my previous webinar, which talked about how to value data. And I realized that data sets where you're likely to gain real insights share a lot of the same dimensions that I talked about in the past, which was things like, does it help us produce, is it predictive in its nature? Is the data of high quality? Is it complete? So the more complete the data sets that we have access to, the more likely you're going to find insights by looking at correlation between different dimensions or different aspects of the data set. If you're looking for opportunities for a lot of organizations, then insights often have the most relevance if they relate to revenue or expenses. So anything that relates to margin, that's where you should be heading, I think, in a lot of cases. Obviously, that only relates to certain types of organizations. Government probably doesn't have the same focus on that, or education as well. And granular data sets. So something that is very transactional typically is where you're going to find those real nuggets of insight, or there's the potential to find them. It's worth calling out as well that not all data sets are going to be as valuable as others. So before going looking for insights, I think it's worth to really challenge what's the likelihood of there being a powerful insight within a particular data set, and choose those data sets where you think they share those qualities that would potentially conceal valuable insights. Now, the 4 paths that we're going to talk about today are stumbling. So with stumbling, that is, there's an element of luck and good fortune. You're doing some self-discovery of a data set. You may have thrown a BI tool across it and doing visualizations, and you're hoping to come across something of interest. We've got theorizing. Theorizing is about where someone, I often use the analogy, someone's on the bus going to work in the morning, and they think, oh, wouldn't it be interesting if I looked for a correlation between temperature, weather patterns, and safety incidents in maintaining a field around a power station, for example. So looking at those ideas, you come at it with an idea, and then you start building the data sets to support the analysis that you then want to do. Discovery analytics is more to do with that classic sort of, we used to call it data science, then it's advanced analytics, and now it's more AI and ML, but it's around having a deep understanding of the algorithms that are available to you, and then choosing which ones that you want to apply to tease out those insights. And brute force is a little more prevalent now, and it's about where you probably don't really understand exactly what it is you're looking for. But we have at our means now with cloud solutions, the compute resources way in excess of what we would have had in the past, and we can just throw these resources at problems and discover things that excuse me, I'm just handing over controls, so excuse me about that. And where we're throwing compute resources at a problem and not necessarily doing it in a way that is prescriptive, but we're opening up the problem to the vast range of tools that we have with us now. All right, at this point, I'm now going to hand over to Matthew, who's going to take you through the stumble in the theorized paths. There may be a little bit of lag as we switch over, so excuse me if the slides start moving straight away.
All right, thanks, Andrew, and good morning, everyone. So, as Andrew said, my name is Matthew De Maria. I'm a consultant with Altis, and I'm going to take us on a bit of a journey down the stumble and theorize paths to finding insights with data. Now, these first two paths do have a bit in common. I like to kind of see them as the uninformed and then the informed paths to generating insights through, I guess, more traditional business intelligence and possibly even data warehousing methods, as opposed to the latter, which are probably more artificial intelligence based. Now, a bit of background on me. I've been consulting with government clients for about 4 years now, doing a lot of business intelligence and data warehousing. So keen to share some of that experience and knowledge, and let's dive in. So the first path we're going to talk about is the stumble path. Now, this is more or less what it sounds like. This is, a situation where you've probably been handed really kind of high-level requirements from a BA and been asked to maybe answer some of business's questions. Or, possibly even more terrifying, you've just been handed a data set and been told, hey, can you find insights? Can you generate value from this? Now, I like to consider this stumbling path to be probably more of a, I guess, data exploration phase. And you definitely can get lucky and stumble across things that might be of value. But I will kind of caution that the reason we're in the stumble path is because it's sort of an uninformed space. And context is hugely important in the information you find being valuable. You can throw different combinations of dimensions and measures into charts, and you will get a lot of information from this. But ultimately, you still need the context to be able to back it up. But still, going down the path, important question that pops up is, can you get lucky? And, you sort of can. Modern BI tools allow us to visualize data really quickly. And pretty much all of them now have really simple drag and drop interfaces that allow us to really quickly explore all dimensions and measures across our data set within a matter of minutes. If there are going to be really standout, interesting characteristics of the data, you will spot them really quickly. And you may stumble across what you're looking for. But once again, information is okay, but insights are more important and context is really important here. They need to be backed up by basic knowledge around the data. Now, while we're kind of on the topic of BI tools as well, we're actually kind of in a position now with them where we almost can skip this exploratory phase and let them do a lot of the work for us. Basically, all the big players now offer some sort of machine learning backed feature to let the tool decide what visualizations might be useful. And anyone who's worked with them will know these kinds of tools do have a long way to go, but it does help us really skip a lot of the stumbling maybe and can save a bit of time there. Now, this is kind of talking in the uninformed space, as I said. really where most of the value in this discussion is talking about our theorized path. Now, I like to think of the theorized path as generating insights through a combination of creativity and a deep understanding of the data. Or another way to think about it is it's a collaboration between two people or two teams. This is a collaboration between your data experts who know your ETL, your BI tools, and possibly a bit of data storytelling skills as well. It's them working with your business users who've been around a data set for 5, 10 years and really can answer a lot of questions to it. I spent a lot of time working in government, and I guess in our case, this is usually your policy areas or your program management teams or the teams that handle reporting. It's a collaborative effort between these two. It's not always like this, so I like to think you can break this pathway down into a further two kind of sub scenarios. At least in my experience, there's usually two different scenarios here. And the first one is you have a depth of knowledge on the data you want to explore, and you have the technical skills to support this. And this is great. Go forth on your own and discover all the questions to answer. This is a really good situation to be in. I was fortunate enough to be with one client for 3 years, and you do honestly get to a point where, like Andrew said, you can be sitting on a bus and have a great idea and this need to explore it, or even more tragically, wake up at 3 a.m. in the morning and just need to dive into the data. Realistically though, more likely it's going to be a situation, especially in our space, where you're going to be working in a team with people who really know the data back to front, and they've got ideas that they need to explore, but probably not the capacity or the time to take up learning the entire BI solution. And it's going to be us helping them find insights. So I'm going to talk about this path and how I like to go about it in terms of a scenario that came up for me a lot when working in government. So you're new to a project and you've been asked to help your client model demand for their services based on different funding scenarios. So in government, this is working out, which policy decisions are going to have the best impact on the program. And the age-old story of any kind of BI problem, right? They have an algorithm manually implanted using spreadsheets to identify different characteristics of the data, maybe not captured in the original source system or not available in their reporting tools. And then it's manually joined to other data sets and you do a bit of modeling there. And in this kind of problem, you can immediately see two halves. You see one side of it where there is an obvious need to automate some data transformation process, your ETL, and that can take a fair few resources. But next to that, you've got a business unit that has ideas, has theories that they want to explore and dive into. So traditionally, I guess this would involve a lot of co-design sessions between a BI team and the business unit. And I'm going to talk about some problems that I've found with doing things this way, and I guess difficulties. And really it all comes down to the fact that sharing years of knowledge is actually pretty hard. And like we said, users with a deep understanding of the data probably don't have capacity in their time at work to develop an analytic solution, hence we wouldn't be there. So the understanding of the data needs to be communicated to developers, which takes a lot of time and resources. And really, at the end of the day, no matter how agile your work process is, ultimately, whoever's driving the mouse and keyboard is going to be making a lot of design decisions that then need to be reviewed, and we go back and forth on this. So something I like to do where possible, and in this government environment, this was the case, is take kind of a bimodal approach. And this will sound familiar to some people who are familiar with Gartner's bimodal approach. I roughly based this off how they do things. So modern BI tools allow business users to rapidly prototype solutions without needing to know any SQL. And of course, they won't always be production quality, and they shouldn't be. But it does allow experts to deep dive and explore ideas. And it's a very good investment to consider upskilling your business units to work with the BI tools. Because ultimately, they can create blueprints for production solutions that can be, I guess, finalized by your BI team and then further developed. And this brilliant thing happens where if you increase the knowledge of your business users in the technical space, you also kind of allow more time to bring your, I guess, technical users closer to the business knowledge. But really, what we want is people testing their theories quickly and then moving on. And that's really where these tools come into their own. So that's more or less how I've handled these situations. And because the client was keen to upskill in developing BI reports, we were able to go through this kind of discovery process with them. Obviously, the BI team needs to help them getting set up. But once you get into this rhythm, you can start to rapidly prototype things. And especially in a situation where in the past, they've already done all the manual modeling and produced some output Excel files. It's easy to load those into a BI tool and just start deep diving into theories. And really the beauty of it is that you can redirect your technical resources to really focusing on the data transformation and automating tasks, which ultimately you've got two streams of work. And when they finally come together and meet up, the BI team do have these blueprints and they can be tied in and implemented with the automatic solution. Obviously, there are many ways to go down kind of a theorized path, and BI and this kind of level of co-design and business involvement isn't going to work for everyone in every situation, but it's something I would highly recommend and has worked really well for me in the past. So before I hand over to Abhishek to talk about more modern ways of handling data analysis, I just want to cover off a couple of things in the BI world that are sort of close to my heart and important to me. And it's this topic of analysis versus reporting is one of them. And they aren't the same. Reporting raises questions to be answered. Consider a KPI report. You're going to see that something's wrong, but it won't necessarily tell you why. Analysis is there to answer the questions. There is so much data that we don't report on that is captured that has this analytic capability to really deliver value and good insights. And we need to start thinking about these two as separate ideas to be able to make the most of our data resources. Reporting is always going to be important, but really in the insights game, we do need to kind of move past it and really go from capturing data to analyzing data. And finally, a point I really love to bring home is that, you know, insights are only going to be as valuable as how well they're presented in the end. And data storytelling is a huge topic, and we'd never have time to cover it off in a single webinar. But I will say that great insights can be lost if they aren't presented in an easy to understand and meaningful way with appropriate context. So context is so important. And so if you are interested in upskilling your data storytelling, there will be plenty of information at the end of this webinar on that. It's a topic I love personally. All right, handing over to you, Abhishek, on that.
Thank you very much for that, Matt. All righty, I'll just take a moment to request control. So I think we've had a good discussion about a couple of the approaches that you can take when it comes to, you know, having a good understanding of where that value in your data lies. But if you don't really have a good understanding of where that point is, then a discovery analytics approach can be a really powerful method to really get an understanding of where you can really start with. So there is a distinction to be made between whether you know what question to ask of your data set and whether you still need to delve deeper to understand where its value lies. This can be where knowing what your known unknowns are and your unknown unknowns are can be really valuable. And AI and machine learning can be really, really useful to get an understanding to help speed up this process. So I'll leave you a moment just to have a quick read over this. At the end of the day, it really is easy to get caught up with all of the buzzwords and all of the marketing that's really provided today in modern media. When it comes to different things like artificial intelligence and machine learning, a lot of them can sound really, really nice and sounds like they're a one-stop shop to solve all your problems. But at the end of the day, you really do need to understand that there is no silver bullet. When it comes to it, even AI itself as a term is misrepresented. And much of what's represented in pop media is what you would consider strong AI. And so strong AI effectively would be like your robot assistant to Iron Man. It'll be that hyper intelligent system where you can have a discussion with it and it'll answer all your questions at a whim. But really what we have in the real world is considered weak AI. And what that means is that it's a purpose-built system that's able to be able to automate specific questions and queries to be able to either augment or replace humans. It can be really, really powerful. And there's nothing to be said about weak AI just because it's coined in that term doesn't necessarily mean that it's not extremely powerful. It's still capable of powering self-driving cars and detecting cancer far better than humans are ever able to. But strong AI as that kind of term doesn't actually currently exist. So there's an importance in having a good understanding of what's actually out there. So the main topic that I'm going to be covering for today is really machine learning and AI and different approaches that you can take. But it's good to have an understanding of what they really are before kind of delving further into them. So at the end of the day, what is machine learning? So machine learning, as defined by the Oxford Dictionary, is the use and development of computer systems that are able to learn and adapt without following explicit instructions. Now, that in itself is a little bit of a generic term, so I would specify that to be a bit more, it's a branch of AI, and that it's designed to be able to generate an algorithm or a model that really imitates the way that humans learn. It's able to improve its accuracy gradually as it's exposed to new data. And so really that extra exposure to data points imitates that learning process. So machine learning in itself, it focuses on either clustering or classifying an input data set based on that model that it's generated. So it can either produce a labeled or an unlabeled output. And there are some distinctions to be made there. Now that sounds fairly obtuse when I say it like that, but we can run through some examples to really describe what this means. A common example of this would be your smartphone camera, and with its ability to be able to recognize faces whenever they're in frame so that it can focus appropriately on the subjects that are in frame. And the only reason it's able to actually do this, to identify your face, is because there's a model that's been built in the background to run this camera, and that it's been supplied with thousands upon thousands of faces to be able to train that model to be able to learn to recognize what a face is. Now, the other distinction to make is really that distinction between machine learning and deep learning and neural networks, because all of those are terms that are thrown around fairly willy-nilly, and it's good to have an understanding of what they actually are. And so really, machine learning is actually the broad category. Deep learning is actually a subset of that category, and a further specialization of that are then neural networks. Effectively, machine learning is kind of that classification of algorithms that you're looking at. Deep learning is that particular subset of those algorithms and that have a main advantage that they're scalable and that they can improve as the data is continued to be provided. And neural networks are then a further subset of that. They're specifically designed to mimic the way that the brain and neurons work. Effectively, they've got different layers of these neurons, these different decision-making processes that are then built to be extremely simple, so they can all be combined to make this very complex approach. But that's a brief overview of what machine learning is, really, to be able to help these type of approaches. The other thing that's worth being aware of when it comes to machine learning is the two main types that are actually available out there. And those are supervised and unsupervised learning. So really those two main distinctions, the main difference between them is whether or not that input and output data set are labeled. So this is something that I mentioned on previously. As you can see with that left-hand example, you've got these different data points that they have an individual labeling. Whereas when it comes to unsupervised, you're more talking about that clustering approach. But to talk more specifically, you start off with supervised learning, and that's the one that actually uses a label to input and outputs. And so because of that, the data set that it actually generates actually has human readable outputs. So they're understandable and intuitive. The only way that it's actually able to do this and to build a model is to be provided a labeled data set so that it can actually build its own definition and recognition of what identify those labels, effectively that way in being trained. Then it's tested to validate its accuracy and see whether or not further training needs to occur. The obvious pitfall when it comes to this type of approach is that it relies on actually having this type of training and testing data set available on hand, something that needs to have hundreds, if not thousands of data points to really get a good understanding. So in that example of the smartphone camera, the camera is only really able to recognize your face due to the thousands upon thousands of pictures of faces that has been provided already. So it can confirm, yes, that is in fact a face. Now contrast this with the unsupervised learning approach, where rather than actually being told directly what to look for, the algorithm is instead tasked to find different clusters or patterns that are inherently available within the data set that may not necessarily actually be easily seen by human observers. And so because of that, what you may notice between the two types of learning is that since the outputs themselves are unlabeled, they won't actually necessarily provide human readable or intuitively understandable results. But that doesn't mean that they're not anywhere equally as useful. The outputs themselves instead are classifications of clusters. Say, for example, if a computer vision algorithm was to be provided with pictures of, let's say, a whole bunch of different animals, it may not know exactly what is a cat or what is a dog and what the distinction is between them, but it still may separate them out as two distinct sets of data if there are enough distinguishing factors between them. Now, one other thing that I'll touch on in this real quick is just that the outputs of this clustering can then be used to inform a then supervised learning approach. And this is considered semi-supervised learning, but that's a whole nother kettle of fish that's a little bit more complex. So I'm mentioning it just for posterity, so you've got a good understanding of what's available within the space, but that's not something that I'm going to be covering very much today. But really, when it comes to unsupervised learning, it can be really, really useful for the discovery of those unknown unknowns. When it comes to that approach that you want to take, that discovery piece is really where you can have a good understanding to discover where the value in your data lies. So let's go for a bit of an example for this to really nail this home. So rolling this into an example, in this case, we're going to hypothetically help a bank identify fraudulent transactions. So in this case, we do actually have a known goal, and our known unknown is who the malicious actors are. So we know exactly what we're trying to do. We just don't know exactly how we're going to get there. So one approach we could take is we could potentially use past examples of fraudulent transactions in a supervised learning context to be able to try to find who these identify who these malicious actors are using their known tactics. However, this obviously very quickly becomes a limiting factor, as the true unknown is what actually defines a fraudulent transaction. So if we're using a list of these different tactics used in the past, we're always going to be backwards facing. So we can only really identify the things that people have used against us previously. So this is a perfect example of where we actually might be better off using an unsupervised learning approach to then try to find outliers in the data instead, and to see the transactions that simply don't fit the norm. Now, obviously, this isn't an end process where this just spits out the transactions that immediately you can identify, but this could serve as the starting point for further investigation. So that way you can mitigate the risk of false positives while still being able to delve through a large data set. This is obviously most appropriate when you've got big data. Instances where you've got thousands and thousands of lines of data, if not millions, that you can't possibly be trudging through by your own hand. So we've talked a little bit about when you've got a particular goal, when you've got a good understanding of what you want to do with your data set, but what happens if you don't actually have as cut a dry a goal that you want to achieve and to get those insights out of? Well, then the solution itself might actually be a little bit more straightforward. And in that case, just a brute force approach. Sometimes it is actually more appropriate just to be able to throw everything in the kitchen sink at the problem. And so because of that, if you're not looking for that standard slew of obvious data points and that obvious questions that you're always going to be asking of that data, you might end up finding something that you weren't necessarily expecting. This can be more appropriate when you've got a real big massive unknowns, and so you don't have a really full understanding of that value of your data set, because that can serve as the basis for a starting point for further investigation. That can serve as a basis so that you can then take a more theorized approach or a discovery analytics approach so that eventually you do end up with some form of insight. This is maybe step one. So looking at another example of how this could be applied, say in this case, you're part of a marketing team that you're trying to find new tactics to put your products on the so-called leading edge when it comes to your consumers. So in this case, your unknown is definitely everything to do with your data set. This is an instance where you don't need to have a full understanding of where that value in your data lies. So one potential approach is to maybe use a clustering algorithm. This is allowing you to identify different cohorts of consumers to be able to cluster them together, because rather than going down the traditional age and sex demographic breakdown, it may make more sense to actually go with a more grouping of consumers and their spending habits, and actually go through a grouping of their data and finding the different insights, because it makes more sense to group people in the ways that they spend rather than necessarily their default demographics. This can then serve as a basis to then ask more worthwhile questions, such as whether specific marketing tactics will be effective with those individual cohorts, or whether or not a particular approach that you want to take is going to be effective. Now, this is an example where it's a solution that you can take even if you don't necessarily have that technical expertise. What I mean by that is there are actually a number of solutions that are simply available on the market that are pre-built and effectively ready to go. I'll give an example of a couple of all-in-one solutions. You've got Data Robot and H2O AI. These are effectively these different types of solutions where they provide an end-to-end approach. It's something where you've got a one-stop shop where it's supposedly meant to meet all of your issues. However, that being said, it's not a silver bullet. It's not going to solve all of your problems in the one go, but it is worth being aware of because it is a potential turnkey solution. So when it comes to it, there is a potential time saving to be had with the implementation of these type of approaches. And there is something to be aware of when it comes to, it is a minimal business knowledge requirement to get into these type of solutions. Really, you can get a lot of insight and data out of it in the modern terms because we've got these complex systems available. But there is a disclaimer to be had there because at the end of the day, it will generate a black box solution, which effectively a solution that you don't necessarily know all the moving parts to, but that may not necessarily be exactly what you're looking for. Case in point, Amazon's 2014 recruiting tool. So we've definitely got the disclaimer of making sure to use the data ethically, and this is a perfect example of this. So Amazon built a recruiting tool back in 2014. Effectively, it was built and trained on past patterns of resumes that were submitted to the company over a 10-year period. And so effectively, because of that, it was then used to filter out a whole bunch of resumes and only filter a handful to the top so that they could then be used by the recruiters to identify who the best candidate would be. However, due to its past patterns, it was actually found to be discriminating against female applicants. And that was simply because the way that it was trained, there was a male dominant in the data set that it was actually provided. Many of the applicants within that 10-year period had been male, as well as many of the people that had been hired. And so because of that, the algorithm effectively taught itself that male candidates were somehow preferable. Now, obviously, this is an example of the risk that you can apply when it comes to these type of black box models, because this model wasn't built to be inherently sexist. Of course it wasn't. But it is an instance where because there were particular skews, because there were particular skewing of the data set, and because that data set had that male dominance in it, the model was simply built to continue with what it was provided. And so because of that, that discriminatory aspect was effectively built in. Now, eventually, obviously, Amazon did actually take this approach and then remove these gender biases, but eventually the whole process was scrapped just because it wasn't fully verifiable that any other forms of discrimination weren't seeping their way into the data set. And so you really need to have a good understanding of what the real world impacts are going to be when you're using these type of approaches. Because at the end of the day, although you may not have any ill intent in your heart, if you do have these type of processes, you have a requirement to understand how they'll actually impact the real world. Now, that was a bit of a crash course when it comes to the different the different discovery analytics and the brute force approaches. But I think you can understand that when it comes to AI and machine learning, there's a lot of value and power that you can get in these data sets. You just have to make sure that you're using them completely appropriately. So now that concludes my portion of today's webinar. I'll hand over now to Andrew to provide a conclusion.
Thank you, Matthew and Abhishek. That was great. I really enjoyed the content. So as you can see, there are a plethora of different options available to us when we're trying to elicit and discover insights. The four that we've listed probably cover the majority, but I'm sure that those of you participating in the webinar will have probably got your own opinions and thoughts about how you find how you found insights in the past. So please feel free to share those in the Q&A or raise questions. I think some of the call outs that I've taken away in my experience and through putting this webinar together is the idea of being able to fail fast. So what I love about some of the things that Matthew was describing is that the current tools allow us to explore ideas, do some discovery, dig into some of those theories that we came up with, and decide whether or not they're worth pursuing very quickly. So we're no longer in that paradigm where data preparation would have taken weeks, and you would have had to build a dashboard which would have taken, you know, another week or so, and then you would see the result and you go, well, that doesn't really tell me what I hoped it would tell me. So I think what the industry's done really well is taken this to a place where we can do that much more quickly. So we can be iterative and we can decide that something's not worth pursuing. The data just doesn't represent what we had imagined it would. Another call out is that the entry level for that more sophisticated AI, ML, data science, advanced analytics is reducing rapidly. So the analytics in a box solutions that we talked about in the last section have really meant that we can throw a technology at a data set and have it explain what it believes is the story within it. But the call out to that is that we really need to have a healthy skepticism about what the answer is. Is it biased in some way? From the Amazon example, is it overfitted? Does it really only describe the data that it's been trained on? And if we put it in the real world, is it accurate after that? So I think coming at it, it's less now about coming at it with a statistical background, but more about coming with a healthy skepticism that we're very easily fooled. And if it's predicting something we want it to predict, very often we're going to believe it. You probably you would have heard the phrase silver bullet multiple times through the presentation. There are no silver bullets, but there are many options. So you can try the stumbling approach and the ad hoc discovery. You can try the theorized approach. So there's now a number of different opportunities for us to pursue the discovery of insights, and which ones are most appropriate for your organization is really going to depend on a lot of different factors. Technology probably a little bit less than it used to be, and more about where you are in your journey, what type of problems you have, the skill sets of your staff, so a whole number of different ranges. And if one doesn't work for you, then there are other options to try. And again, the industry's been very good in allowing us to try multiple things and not necessarily having to commit to any of them from a large expense perspective. Not all data sets contain nuggets. I wish they did, you know, so before you start going looking for insights, make sure that you've really sanity checked. Is this data set likely to even contain any? And going back to one of the points that Matthew raised, which was, let's try and do more analyzing and less reporting. I'm afraid I still see lots of written requirements that ask for operational reports that really just told us how many widgets we sold, but didn't really tell us why were they sold, how did it change, what was the underlying trend, are there other opportunities to visualize the data? So let's move beyond that traditional reporting and more into the analyzing and value add. Now, the next slide will allow us to have some questions. I'm just going to have a quick look in Q&A and see if we have any. I don't believe I've seen any pop up. No, I don't have any there. Please use this as an opportunity to reach out to Altis. If you please, reach out to Matthew, Abhishek, myself. Reach out to your local regional manager. As I mentioned before, we have offices in Auckland, Melbourne, Sydney, ACT, Brisbane, London. So reach out to any of my colleagues or regional managers. We have all the normal connection points via social media. One point that I want to call out, which is I've been reminded by my marketing department that as a result of participating in this webinar, then there is a 20% discount available for our public training. So we have a dedicated training department. I should also mention that we have an AI ML practice, which would love to hear about some of your problems. So if you have anything that you would like to bounce around, please reach out to us. We're always intrigued by the problems that we get presented with. I guess in summary, thank you for participating in this webinar and staying with us. I can see that we've probably got roughly the same number of participants we had at the end as when we started. Normally we see a drift off over the course of the webinar. So thank you for staying the duration. Would love to speak to you offline, continuing on from this webinar. So please reach out. And at that point, I think I will wind up. Matthew and Abhishek, thank you for your participation. And I will close down the webinar. Thank you.